Oh, that's 6th grade. There's number 7. Mr. Elijah Fisher, sir.
How did you do the number 3?
3, how would I do it? It looks like a unit multiplier problem to me. This is what I would do. The machine can produce 120 plastic dinosaurs in 8 minutes. In 8 minutes. So take what they give you. You can do 120 plastic dinosaurs in 8 minutes. I will need to change minutes into hours. So how do I get minutes to cross off? What's on the bottom? I put minutes on top. I'm changing it into HRs. And you just need to know the conversion for those. What is it? There are 60 minutes in 1 hour. The rest is just math. However you want to do it, you could reduce this and then multiply by that. You could multiply those two and then divide by 8. Here, I'll reduce this. 4 goes into both of these. 8 probably goes into it. Yeah, 8 goes into it 45 times if you're right. No, 8 goes into it 15 times. And then 15 times 60 is probably 900. 900 per hour. You can do the math on that. If you can't do the math, then you're in the world of hurt. What?
Oh, is that just like reduced?
Yeah, I reduced 8 goes into 120 15 times, and 15 times 60. You multiply the top stuff by the bottom stuff. Drew Nordquist.
I didn't number 17.
Number 17 is on the proverbial table. 13, 14. I'm going to get to number 17 if I can find it. Ah. Oh boy. Everybody loves to talk about combining like terms. What do we know about like terms? They have to have the same variables to the same exponents. Which ones are alike there, Drew? Again.
5x squared and x squared.
So if you have 5x squared and you put another x squared with it, how many x squareds do we now have? No,
Oh.
5 and 1 to me every time has been. Now you have 6x squareds. You're adding. How about with the x's? Well, minus 3x's and another minus x. And you can think about it like this. Minus 3x means you have 3 negative x's. And here you have another negative x. How many negative x's does one have there? 4 of them. A negative 3 and a negative 1 is a negative 4. You're not multiplying, you're combining. Or combining. Mitch?
When there's like the positive or negative symbols, does that mean like the number is negative or positive, or is
Yes and yes.
Okay.
Subtracting and negatives are the same spiely bopper there. Negative 3 minus 1 or negative 3 and the negative 1, they're both negative 4. Mitch?
18.
Oh, look. 18 is the kind of the same thing, except you have to do what little property first before you can combine? The distributive property. What do I do with this? I have my 3x that stays. What's 2 times x? Mitch?
2x.
2x. What's 2 times a negative y?
Negative 2y.
Negative 2y. And here we go, same old story. I have 3 x's. The x's can be put together. You have 3 x's and another 2 x's. That's a grand total of
5x's.
And the 2y does not, because just like 7th graders, sometimes they can be a little on the snooty side. What x's and y's are not getting along at this time. Now if you're multiplying, then I guess they get along, because then they combine to be an xy. Maybe they get married, I guess. In some strange fashion. Oh, that's all the questions. M!
Number 16.
Number 16. I knew it was too different. What's the thing to remember on 16? In order of operations, this little fraction line is a grouping symbol, which means you've got to figure out what the top is, put it on top, figure out what the bottom is, put it on bottom, and then you can do the division is what that fraction line means. Well, what is 1.2 minus 0.12? If you do that subtraction here, a little borrowing there, you get 8, 0, I get 1.08. Did you get that out? Don't raise your hand in the middle of this, because I think I did something wrong. Unless you don't know why. And then what do you get when you multiply 0.12 times 2? You should get 0.24. 2 decimal places, 2 decimal places. And then, ladies and gentlemen, you have to do that division out. Bottom one goes on the outside. 0.24 into 1.08. We still struggle a little with division by decimals. What do you have to do? You move the decimal out of here 2 places, move it there 2 places, it goes straight up there. 24 goes to 108. Uh-oh, did not work out. What's that? 4 is 96. Subtract 120. Yeah, 4.5. Right next to number 7 right there. 4.5. Riley O'Harrington.
How do you do number 4?
6, 7, 8, 9, 10, 2, 3, 1. Use the multiplier to convert 123 feet to yards. Same thing we just did there. Here's what you're given, Riley. You make a fraction out of it. It is 123 feet. And remember, labels are the absolute most crucial thing here. Yards are on bottom. I am going to cancel. I need to change my, I'm sorry, 123 feet to yards. Yeah, I need to change my, I'm sorry. I need to change my feet into yards. I know I have 123, I'm going 2 yards, so where does feet go? To get this label to cross off, it has to go where on the other one? And what has to go on top? And I know there's 3 feet in the yard because it told me so. Feet have crossed off. You end up with 123 divided by 3, which is 41. And what label's left? Yards. Yeah, don't put the yards down there. It's 123 feet is what you started with, yards is what you finished. Brianna.
Number 15.
Number 15. I like how I keep bouncing. Number 15. First things first, let's do the number. What is 2 to the 3rd power? 2 times 2 times 2 is 8. What do you do when you have x's on top? So you add their exponents. What's a -1 and a 3 added together? 2. And y to the 0 power, which is anything to the 0 power, is 1. Well, if I multiply 8x squared by 1, guess what I get? 8x squared. Multiplying by 1 does not change anything. So this y to the 0 power, in essence, just crosses off. It's a 1, but it ends up being 8x squared because you multiply by the 1. Did I use that wrong? You're doing it now, Elijah, just to make me paranoid. Where'd you go wrong there, Brianna? Just out of curiosity, what'd you get for an answer?
Well, I didn't,
Or what did you have for an answer? How about I'll ask that?
I had 2 to the 3rd power over x squared.
Yeah, that x squared, I don't know where, the x, this was already positive, so you wouldn't bring it down there. You could bring that x down there, but then it's gonna cross, one x is gonna cross off with 3 of those, it's better just to combine them together up there. That's figured out. Elijah,
I, for 7, I got 60,000. You get 70,000.
for 7? Well, first of all, I didn't get it, look at it. They could be wrong, but probably not. But let's look and see, because I am intrigued. Holy smokes, 5 houses in the neighborhood sold this month for the following. The houses with the highest selling price sold for how much more than the median selling price? So you want to direct my ways. First of all, it asked you for the you need to know what the median selling price is. How in the wide world of the proverbial sports do you get medians? Keith Stewart.
Load up my stickers and then pick them up.
Yeah, you need to order them from least to greatest, and whatever number falls in the middle is the median. Did you order from least to greatest? Alright, so here we go, let's do that. Smallest number, 297,500. Next smallest, 328,000, right? Next smallest, 345,000. Now our next biggest, whatever, 389,000. And the biggest one is 415,000. Fortunately for all of us, it's an odd number. What is in the middle of 5 numbers? I have 5 houses there, so 5 prices. Here is your median. 345,000 is your median. It said the house with the highest selling price, which was this, sold for how much more than the median? So you have to do your subtracting. 415,000 minus 345,000. I believe it is 70,000 if I do the math right. Where'd you go wrong there, Elijah?
When I was trying to subtract 1 from 4 when
It always goes wrong at subtracting. It's like the blueberries. It always goes wrong at the dessert. You made this what? Made it a 0?
Yeah, I made it 10 stuff.
Man, this is probably gonna be an easy test. Can't wait for it. Cameron, Colquitt, number 2. Number 2, although 6 of Simon's answers were incorrect, 85% of his answers were correct. What, Danny Baumgartner, should I do here for this? Somebody, Josh? Somebody know where I'm going, Jason? Make a table, make a percent box. That's what I would do. Yeah, you may end up multiplying, I don't know, but this is certainly to organize my thoughts. Here's what I do. What are we comparing? We got his incorrect and his correct answers, and then you've got his total. You've got his percent, and you've got the actual here. How many? Simon's answers were, although 6 of his answers were incorrect, so incorrect were 6 actual answers. 85% of his answers were correct, so that goes in the percent correct there. How many questions did he answer in all? Well, filling in the blanks, what else can I do there, Lady Kavarik?
Do the 15%.
You know, he must have got 15 incorrect because you take the 100% total. And which one am I looking for? How many questions did he answer in all? I don't really need this part of my table anymore. I need to take 15 over this 100 equals 6 over some number there. Easiest way to do it, somebody, anybody out there, I'll take. Aubrey says I have absolutely no idea how to do that problem. Emily?
What did you multiply 100 times 6 and say 15?
Sure, that's one way to do it. You can always do cross products. 100 times 6 is 600, and that has to equal 15 times n. So you just end up dividing 15 into 600, which is 40. Or you could have looked at this and said, okay, this can be reduced. Divide both by 5, it's 3 over 20. Wait, did I do that wrong? Wait, 3 over what? 30, I put 30, 10 makes sense. And then 3 times 2 is 6, so 20 times 2 is 40. Either way is perfectly acceptable, whichever way floats your mathematical boat. M?
Number 6.
Number 6, is that on this side or the other side? Yeah, this is a good one, I like this one here. Find the measure of angle x. Well, they give you this, first of all, you need to know this is 90 degrees. That goes without saying, right? Square box, square corner, 90 degrees. Remember, a triangle notes to self. How many degrees are in a triangle? True. There's 180 degrees in here. 90 of which you know are right here. So I gotta come up with the other 90 between this angle and that angle. Well, in order to figure out this angle, I need to figure out this angle here. How do I know how many degrees this angle is? Jay, shoot!
There's on the other side, it says 130.
And I know that those two angles together are called supplementary, which means they have to form a straight line, which means they have to be how many degrees? And so this has to be how many degrees? 50. So if this is 50 degrees, what number added to 50 degrees gives me the other 90 degrees that I need to make this up? Because I already have 90 of those 180, I'll take that away. I know the 50, I take that away, and I'm left with x has to be 40 degrees. No other choice.
I thought it was 25 degrees because it's an equilateral triangle.
It is not an equilateral triangle.
It's a side on the side.
They didn't tell you that any sides were equal, nor did they give you any of these marks. Equilateral triangles, all the angles have to be 60 degrees. And equilateral triangles, all angles are
I
equal.
thought once the angles were the same to me that I just knew.
No, you can't, and that's one thing in math, you can't go by what looks, it has to be stated to you. Now, you might have thought that this was an isosceles triangle. In isosceles triangles, those two opposite sides would be equal, but it didn't. You can't ever in math, unless it tells you, you cannot go, well, it looked like this. I can definitely say this is 90 degrees because they put that corner there, which is what that means, but everything else, it has to be able to be proven. Welcome to the world of geometry and proofs. Josh?
How do you do number 5?
No, numero cinco primero. Right over here. Number 5. Square of vertices there is dilated from the original scale factor. Do you need to graph this? Absolutely positively not. I just ask you for what the coordinates are. If something is dilated, note to self, dilated means it gets bigger. When they dilate your eyes, your pupils, they blow them bad boys up so you can look in your eyes. With a scale factor of 3, what does that mean? You are just multiplying everything by 3. So your answers are just going to be this. You don't need to draw this. It didn't say to draw, did it? Nope. 2 times 3, this becomes 6 comma 6. Times 3 times 3, negative 3, 6. Times 3 times 3, negative 3, negative 3. Times 3 times 3. All you're doing is multiplying all of those by 3. Did I do something wrong? Yeah.
Do we need to draw it?
You don't need to draw that. Now, if it would ask you to find the area of both of those, then yes, because you gotta be able to see it. But if they just ask you what are the new coordinates, you don't need, drawing would not be required for that sort of. That help, Josh? Jot that down on a piece of notepaper, because I'm pretty sure in tomorrow's test they'll say, here's a square with vertical, blah, 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 blah. What if it was dilated by a scale factor of 2? That shouldn't be too terribly difficult. Mr. Colquitt, sir? Number 14.
Well, I just have a question. Do you,
Well, I'm gonna look at it. Do I what?
do you just make it you have to like do instead of like 4 times 10?
I would definitely do it. I would definitely do it in scientific notation. I wouldn't make it 40,000 times 3,000, whatever. Because it's just like, Cameron says this. To do this, you just multiply these two numbers together, you get 12. You write down your times 10. What do you do with this and this, ladies and gentlemen? What do you do to their exponents? Here's where it gets a little tricky. Again, note to self. I don't multiply the 4 times the 3. I actually add them together. And then I have the wrong answer simply because it's not in scientific notation anymore. What do you have to do? You need to take the decimal so it's between 1 and 10. So you need to move this one place this way. I made this one smaller, so I made this one bigger. My answer becomes 1.2 times 10 to the 8th power. I definitely wouldn't make it. I mean, if you really wanted to, but that's going to be a hard way to go in life when you get to some of these harder. You need to be able to work with scientific notation, adding, subtracting, multiplying, and or dividing. Go.
For scientific notation, has to be between 1 and 10, correct?
Exactly. 1.3. 12 is not, so I moved it up. Mitch.
Number 10.
Is that on this side or the other side?
Other side.
Right here. A bag contains 10 red, 20 white, and 30 blue. If one marble is drawn from the bag, what's the probability that the marble is? Probability of the marble is not red. Now, generally, I would tell you to draw a bag and put all those in there, but that's kind of a lot of marbles to draw in a bag. You probably could figure it out without that, because the probability of not red would be the not red marbles over the total number of marbles in the bag. How many total marbles are there, Mitch?
60.
60. How many of those 60 marbles are not red?
50.
And if I reduce 50 over 60,
5, 6.
then what was the answer?
5, 6.
Where did you go wrong?
I have 1/6 because
That's what the probability of ones that were red.
yeah.
But it doesn't ask you for that. It says what's the probability that a marble is not red. So note to self, read the problem. Answer the question asked. Life is much better. Price? Nothing? Decent this one? Cameron? 11. It's a gem of a problem. Same thing we did when we did that percent problem. Cameron, there's 2 different ways to do this. Your call. Easiest way, if you don't know what you're doing, it's always cross products. This times this, 20 times x has to equal what you get when you multiply 12 times 35. Well, 12 times 35, if you do the math there, looks like it's what? 70 and 35, 420. And what do I do to solve this? Divide by 20. Divide by 20. Oh, what is that? 21. Now, if another way to do this would be to take this and say, oh, I can reduce this. 12 and 20, what number goes into 12 and 20? Let's go higher, let's go 4. 4 goes into 12 3 times, 4 goes into 25 times, and there you go, you can just do 5 times 7, 3 times 7 is 21. Whichever way you prefer. Josh!
Number 12.
Number 12, another one of my favorite problems. You know, we're done with doing these by inspection, now you just have to do using those operations of equality with equations there. I want to get my letter x by itself. The first thing I do is what? I need to get rid of this and I need to get rid of that 3. But the first one I do is, Kate?
So, 1.8.
Yeah, you do the opposite of adding 1.8, which means you subtract 1.8. I subtract 1.8 from 6.0, I end up with 4.2. And then my last step, generally when I'm solving the equation, is to do what, Luke Franklin?
Divide.
By, yeah, divide 3 into it, divide 3 into that. You can do the math, but it ends up being 1.4. Okay,
20.
about 20. A diameter of a cylindrical barrel was 20 inches. What a barrel was lifted away, it left an imprint of a circle. We know what's the area of the circle. Did you write down the formula for the area of the circle, sir? Did you draw the circle?
Yep.
What was the diameter of your circle?
20.
What was the formula for the area of your circle?
Pi times radius times radius.
Area equals pi times radius times radius. What is pi?
3.14.
2.14. What's the radius?
10.
So you multiply 10 times 10 to 100. How did you get your answer from there? Because you're well on your way to the right answer. I don't know where you were wrong. The answer is 314, which is what 10 times 10 is 100, and 100 times 3.14 with the decimal 2 places is 314.
Forgot to multiply it by 10 again.
Gone today, anybody?
Bring Delaney in back.
Delaney's here.
Oh, you came back.
She did
I'll be
speak.
so surprised.
Yeah, Francis.
She was like the stealth. Anybody else? Mitch?
19.
I'm not sure 19 I can really do anything with, except you just know that that is a net, which means if you fold that bad boy back up together, what's it gonna look like? If you fold on all these lines, and you fold those up, is it a prism, a cylinder, a pyramid, or a cone?
That was a prism.
Huh?
That was a prism.
Now, anything that has 4 points and it looks like a star is always gonna fold to give you a point on the top for a prisms will look like this as nets. There would be square corners so that when you fold the box, you get something that doesn't come to a point. If it has little points on it, you're probably gonna get some points in here. That is the point. We've done almost all of them? No. Nothing on this one? Divide left, what do you do? What's the difference? Might as well talk about it since we have a little time. How is this different than the multiplication one? This is the division one. So you divide the left-hand side, which gives you 1.6. What's the difference here? You do not add exponents there, but on division, you subtract them. So you'll end up with 10 to the third power. 1.6 times 10 to the third power. Make sure that that first number is between 1 and 10, otherwise you gotta change it. And then, how about this one? I always like it to see them all going up in big. Right, well, let's be over here. I don't know. Nobody has issues with 8, 9, or 1? Don't forget, negative exponents means it's a decimal number. Shoot, which one are you looking at? Number 8. Okay, negative exponents mean you move the decimal backwards, it becomes a decimal number. And you move it at 5 places backwards. One of those places gets taken up by the 8, so there's 4 zeros in front of that. You just take the decimal and come back 1, 2, 3, 4, 5. So it's going to be 0.00008 as a decimal in standard form. You know, this one just asks you to make a table. Hopefully you did that. That's where the graph came from. Y equals x minus 2. You made a table of x and y. Where do I get my x numbers from? You make them up. It's yours. You always use 0, maybe 2, 4, whatever. 0 minus 2 is negative 2. 2 minus 2 is 0. 4 minus 2 is 2. And then those are the coordinates that on your graph 0, negative 2, 2, 0, and 4, 2, you graph and you get your line. So pretty straight line. And nice arrows. That's it? Game, set, match? If I remember, I have email addresses. Maybe I'll throw this out.